or there might be malicious sensors. Hazard measurements might be too sparse, and it is desirable to increase spatial density of sensor readings. And the hazard elimination might be desirable if large-scale damage could be prevented or minimized by expedient hazard containment. So while the hazard is small, it might be much easier to contain. And our approach was to deploy more sensors using the robot, and then kind of try to demonstrate a new application of robotics for hazard prevention and small hazard containment. And again, I'm showing this movie just for amusement, pretty much, because I brought a hairdryer from home. We put it on the platform, and we used the robot to move closer to the hazard. The robotic arm is going to turn on the hairdryer and extinguish the fire. Now, I'm saying that it's for your amusement because many times I'm trying to demonstrate to our funding agency that there is a potential. I'm not saying that this is the way how it would operate in a real case, but you can see the concept. So that's how it works. And if you are interested in learning more about this kind of work, we published several papers on the remote robot control. The fusion issue we addressed in one paper, the repeatability assessment of the gesture recognition and the whole classification algorithm. The localization and stereo fusion, one of my master students just graduated, so he has a master thesis about it, and we have some papers. The measurement calibration, again, we have a set of papers, and one student graduated about 2 years ago. And then the system design issues, they are summarized in the technical report because I'm trying to summarize our work so other people can learn. There are also publications about the hyperspectral image analysis, but again, we haven't figured out fully how to do the fire classification. There are some journal papers that are related to our past work. Relevance to security research. So you are all coming to the security seminar. And what I want to convey to you is that building hazard-aware spaces requires an interdisciplinary team and expertise, as demonstrated in the presentation. And security is critical to protect information and to have safe operation of hazard-aware spaces. I just want to emphasize that these wireless sensor networks are used for emergency and life-critical applications, so we want to make sure that nobody is going to mess up the system. And the question is how to build into a system data confidentiality, data authentication, and data freshness in this resource-constrained environment. From my perspective, from the application viewpoint, security is really needed for the wireless robot control, the fusion of multiple robot controls, the communication of the wireless sensor networks, the sensor programming. If it starts to be wireless, we have to be concerned about it. The camera control, we don't want the intruder to use the camera for doing something else that it's supposed to do, and the video transmission. So in general, I would say the need is to build some kind of security services for multi-instrument measurement system. That what would be really useful for the wireless sensor networks, for the data gathering aspect from multiple instruments, and then for the fusion, for the multi-instrument sensor data integration. Because remember that in many of the applications, eventually when you graduate and you get a job, most of the top 3 application requirements are accuracy, reliability, and security. I also want to say that there are applications of my interest. There are some ongoing wireless sensor network projects funded by multiple agencies, and the red ones I highlighted because I'm involved in those. So I will just mention that NSF has spent a lot of money on funding these sensor projects. For example, CLEANER is the environmental engineering project that deals with deploying sensors and measuring some environmental variables so they can predict, let's say, the waste management and the nutrient nitrate nitrogen levels in rivers. KUHASI is another project which is more about hydrology. And again, it's concerned about data acquisition and using remote sensing data and ground data and putting that together. SHIELD is a very interesting project, and I'm on the advisory board of that project, where they are trying to embed sensors into bulldozers, tractors, and so forth. It's led by Caterpillar. And why? Because it's so expensive to repair these big big vehicles. So it's much cheaper for them to embed these sensors, and the sensors will report when there is a material fatigue. So that's another one. And then the healthcare monitoring, clearly for the healthcare at home, hospitals, battlefields, and so forth. I just want to mention that what I'm trying to show is that the integration is really transferable to other application domains. The multi-instrument measurement systems are present in many engineering applications, and there are application-specific instrument sensors, but the information processing issues are similar. And therefore, I kind of started to use the word X-Informatics because it refers to the process of processing the data. And if you are interested, there is a book that's just coming out this month, Hydroinformatics. I wrote about 250 pages. The whole book has about 650 pages that deals just with the informatics issues in the hydrology. So if you are interested, there are bioinformatics books, and I published one book chapter here, which is dealing again with informatics issues. But as I am saying, it's very transferable. And then guess what could be on this slide? It's not just hydroinformatics and bioinformatics. It could be also sensor informatics. So to summarize the talk, I really wanted to just overview the research and development of these complex systems, introduce you to hazard-aware spaces, and then kind of show you the integration aspects of data across disparate sensing systems over time, space, and variables. If you are interested, or it sounds very interesting, please visit our websites. There are publications, and you can ask me questions. I will probably conclude the slide with the following, the presentation with the following picture. My question for the audience is, do you know where these pictures came from? These are the pictures of the Hurricane Katrina. And the reason why I put them up is that they are beautiful, but if you think about it, if you would change the whole scenario, and instead of trying to deal with the whole scenario after the hurricane hit the coast, you could have posed the question, could we have stopped the hurricane? And my gut feeling is that the person, or maybe the next generation like you, would figure out this problem by really building multi-instrument and multi-sensor systems. And you can imagine how many sensors and instruments you have to deploy to fully understand the whole hurricane, so you can figure out how to stop the hurricane as opposed to deal with the consequences of that. So that would be my concluding remark, just something to think about. Thank you. If you have questions, please ask me.